Share screen. Okay, and then moving is just going right and left. So yeah, keypad. So I'll bring the computer closer so that yeah,
Okay, thank
so I
you.
can hear you well.
So you're good.
Yeah.
Great.
Right.
Thank
Yeah.
you.
Take it away.
Hello, I'm Samira Faizi, postdoctoral researcher at PAM. Today, we are going to talk and learn about ash analysis or ashing together. So, the first question, which is necessary for this lecture, is the definition of ash. Um, can you define ash or ash content? Any idea? Yeah,
Ash is inorganic matter.
of course. Right. Any other? What we define inorganic matter?
So like I think it's anything that isn't protein, fats, it's kind of like a negative. So it's not carbs, not fats, not protein.
Vitamins.
Yeah.
Correct. Great. Thank you. Yes. So organic matters, oxidize them. They convert to CO2 or NO compound, and then they can get out of our system. But in organic matter, once we combust the sample, they remain. And so they are mainly minerals like sodium, cadmium, iron, calcium. And so what is left after burning of organic compounds are named inorganic compounds or ash. Why is it important to do ash analysis? Why do we need ash content, ash analysis? Yeah.
Does it help figure out the materials?
Um, So for organic material, we can determine the content of the protein content, total carb content, fat. So it's very, very indirect method if you want to determine the amount of organic compounds based on inorganic compounds. But okay, yeah. Yeah, of course. Thank you. Yes, yes. So, as you see, for nutritional labeling, sometimes we need to determine the amount of sodium, the amount of calcium, iron, and other minerals. So, for nutrition labeling, we need to do ash analysis, and it is important. And the other important thing other than elements. So sometimes we want to determine the total carb content, and ashing and ash analysis is a way to determine the amount of total carb content based on subtraction of ash, moisture, protein, and fat from 100 so that we can determine total carb content as well. So for nutrition labeling, and for determination of minerals, we need to do ashing or ash analysis. There are different methods for ash analysis, but before we get to ash analysis, we need to do a good sample preparation or sample prep. So you have different food products, food ingredients, and they have different features. Some of them have high moisture content, some of them have high fat content, or have high sugar content. So when we want to do ashing, the first step is to make sure our sample is homogeneous and representative of our main and large sample size. So To do sample prep, if your sample is a plant material, let's say a plant material, a leaf, or meat, which have high moisture content, the first step is to reduce the amount of moisture. Why? Because when you put the sample in the crucible and put it in the oven at high temperature, like 500 degrees Celsius or 50 degrees Celsius, there is a possibility of spattering. So we need to dry our sample to reduce the amount of water or moisture to make sure that once you put your sample at high temperature, you don't lose your sample and there is no possibility of underestimation of ash content. Sometimes your sample has high fat content, like cream cheese, like some meat samples. When the fat content is high, if you put your sample in crucible and put it in the oven, in the muffle furnace at high temperature, there is a possibility of burning or smoking because of that high fat content. So here we need to do fat extraction before we do ashing or ash analysis. For some samples, there is a high amount of sugar in your sample. Then again, you need to do drying to make sure that once you put your sample in muffle furnace at high temperature, there is no possibility of foaming and losing the sample. So before we do ash analysis, we need to make sure we are doing a good sample prep. Drying, grinding, and pay attention when we are doing grinding or milling, which is required to make sure that our sample is homogeneous. As for some samples like flour, like different grains, different legumes, you need to grind them. But there is a possibility of contamination to different metals and elements. And so we need to do a good sample prep to make sure we are not losing our sample and we are not going to do an overestimation or underestimation while determining minerals or determining the total ash content. There are different methods for ashing: dry ashing, wet ashing, and microwave ashing. The first two, dry ashing and wet ashing, are AOAC methods. Microwave ashing is a fast method, but is not an AOAC method. So if you are doing ashing to determine the amount of minerals for nutrition labeling, you cannot use microwave ashing. You should use either dry ashing or wet ashing. So dry ashing. For dry ashing, we need muffle furnace that can provide high temperature and be stable at like 500 degrees Celsius or 550 degrees Celsius. So you put your sample after sample preparation, you put your sample very dry crucible, put your sample in crucible, and then put it in muffle furnace. Adjust the temperature at 500 degrees Celsius and leave it there for certain amount of time. It's a long procedure. Usually you need something like between 18 hours to 30 hours. So it's really, really time consuming, a lengthy method, but it's a very, very common method. Dry ash. When you are doing dry ashing, it's important to choose an appropriate crucible depending on your sample and the analysis you are going to do. So there are different crucibles available. And the other point about dry ashing before I to crucibles. So when you are doing dry ashing, there is oxygen in the atmosphere. And then we have organic matters, protein, fat, carbohydrates, vitamins. And then your sample might have some amount of moisture. There is a moisture content in all samples. So that helps presence of oxygen, high temperature, and organic compounds. That helps combustion and burning of your sample. I mean, organic part of your sample. And then it converts to CO2, NO2, and it gets out of your sample as gas. So what is left in your sample is inorganic compounds that cannot be combusted and cannot get oxidized. So about crucibles. Probably the most common crucible which is available in all labs is porcelain crucible. Their price is reasonable. They are good resistant to high temperature. The only point is that they are sensitive to temperature fluctuation. So once your ashing is done at 500 degrees Celsius, you cannot take them out. You should leave them there so that the temperature goes down, they cool down, and then take them out of the muffle furnace. And make sure the muffle furnace is closed so that the moisture doesn't get in. And they are so common. Probably the crucible you are working in lab and using them are porcelain ones. Quartz crucibles, they are expensive, resistant to acid, very good crucibles. The point is that they are expensive and probably they are not common in general labs. The other type of crucibles are this type, which are quartz fiber. They are similar to quartz crucibles. The only point is that type of this material is porous so that it helps air circulation and then heat transfer is fast. So this is the only plus we can put for quartz fiber crucibles. Silk crucibles, the only point, negative point that these silk crucibles have is that they have different elements like iron and nickel. So if you want to do determine the amount of minerals in your sample, this type of crucibles are not good. So because they result in contamination of your sample, and you might have erroneous results. The other type crucibles are platinum. They are resistant to acid and alkaline conditions. So, but they are expensive, really, really expensive. And so they are not common in general labs and assays. So for dry ashing, if you want to say advantages of this method, it's a simple method. It doesn't need much of your attention as an operator. You just make sure your crucible is well dried, weigh your sample, put it in muffle furnace, and leave it there for 24 hours, 30 hours, 18 hours. How can we make sure? Here is a question. How can we make sure when we are doing dry ashing, ashing is complete and it's not incomplete? Any idea?
I will say that in lab, they said something about like color.
Mm-hmm.
With it,
Exactly.
when it's darkish color, it wasn't complete, and then when it turned sort of like a blackish, right?
Mm-hmm.
It's-
Yes. So if you open the muffle furnace and see the compound which is left in crucible is brown or black, it shows ashing is not complete yet. Once it turns to white or light gray, it means ashing is complete and you are not overestimating ash content of your sample, and you can trust your. So this method is simple, is safe, it doesn't need any reagents, you don't need to consider any blank for any type of correction in your samples. And the other positive point is that depending on the size of your muffle furnace, you can put a lot of samples at the same time, as many as you can. So 40 crucibles, 50 crucibles, depending on the size of your muffle furnace. So there are some advantages, but the disadvantages. It's so lengthy, time-consuming method, and if you don't pay attention to complete ashing or incomplete ashing or good sample preparation that cause loss of your sample because of foaming, because of smoking or burning, or because of spattering, then you need to repeat this assay, which is really, really time consuming. The other point is that you are doing dry ashing at really, really high temperature, 500 degrees Celsius. At this high temperature, there is a possibility of volatilization of some elements like iron, like phosphor, like calcium. So still there is a possibility of underestimation. Okay, we talked about dry ash. Can you tell us some sources of error in dry ashing that might result in erroneous results based on what we talked so far?
Moisture,
Yes. Wrong sample prep. Yeah.
So like you said earlier, in the minerals, like.
Yeah, there is a possibility of loss of minerals because of volatilization. Yes. Incomplete ashing. Any other idea? Okay. So the first thing is that, so you are getting small amount of your sample. If you don't do a good sampling or sample preparation, your sample cannot be representative of the whole population of your sample. So it's the first step that we need to make sure our sample is homogeneous and representative of the whole sample population. And that might be a source of it. The other thing is that if we don't use an appropriate crucible, there is a possibility of contamination to different elements. Or if we don't pay attention to contaminations, there is a possibility of different contaminations. And then, as you said, loss of our sample because of volatilization of some elements and incomplete ashing or combustion. Okay, question for you. Bad news, you need to do some math. Good news, if you be active, you will have plus. Okay. The following data was obtained on a sample of hamburger, 47% moisture on wet spaces. 47% moisture on wet spaces, 56.6% fat on dry basis, and 1.14% ash on wet basis. What is the ash percentage based on dry basis? So I give you enough time. You can think. The hint for this question is that you need to pay attention to wet basis and dry basis. Okay, if you appreciate result, answer, share.
I got 2.1 points. And
2 point, yeah, correct. Any other? No. Okay. So then we have 47% moisture based on bed spaces. Then the amount of total solid we have will be 53%. That means 53 gram total solid based on wet bases. And then consider you have 100 gram total solid based on ice. If you patch content here, then it is based on bed basis. It's 1.1, 1.14. And how much it will be when it is 100? So it will be 2,000. You think? Is it clear? If you have any questions, just I can explain. So, point is that we need to pay attention to wet bases and dry bases. Okay, good. Next question. The following data was obtained on a sample of hamburger. Again, 47% moisture on wet basis. Again, 56.6% fat on dry basis. And 1.14% ash on wet basis. What is the ash percentage on fat-free basis? The hint for this question is that you need to convert to wet spaces. Yeah.
So fat-free basis as in like dry fat-free basis.
So
Oh,
fat-free basis means consider there is no fat in your sample. Calculate the amount of your sample without any fat. And then here is the point. You have, if I answer that, I answered the question. Yeah, the hint is that you need to work based on wet basis. I mean, that is the easiest way. Any progress? Any answer? You have the answer? No.
Yeah, I'm getting 1.6. So
Yes, correct. Okay. So the same as the first question. First step is to calculate the amount of total solid you have. So 53%. Now, you have 56.6% fat on dry basis. So then you have 56.6 gram fat. Based on dry. Okay, and it's dry. Then in your wet sample, total solid content was 53. How much would be your fat content when you have 53 gram total solid and you're in your wet sample? So here, the X, the amount of fat in your wet sample will be 30 grams, or let's say 13%. So this is the amount of fat in your wet sample. Okay? So total solid of your wet sample after removing the fat from it will be 70%, because we need to work based on fat-free basis. So we need to remove this amount from our wet sample. So you will have 15% fat-free sample based on wet basis. So that means 50 gram fat-free total solid in your wet sample. This sample has 1.14 gram ash. Based on the information you have here. Okay. Then, if you have 100 gram total solid in your dry sample, how much would be your ash count? 1.63% or gram per 100. Yeah. So the first step was that, okay, we have 47% moisture content. What is the total sum? 100 minus 47%. 53% total sum based on metrics. We have this amount of fat in our dry sum. Then I need to determine the amount of fat in my wet sum. So 56.6 gram fat in my dry sample if I have 100 gram total solid dry sample. Then in my wet sample, I have 3 gram total solid in my wet sample. So how much is the amount of fat in my wet sample? 30% fat in my wet sample. Then, okay, I have some fat. What does fat mean? We need to remove the fat from the other compounds. So 70% fat. If I have 7 gram total solid in my fat-free sample, which is wet, imagine you have 1.14 gram ash in this wet sample. How much will be the amount of ash if I have solid in my glass? So this is it. Again, if you have any question, ask. Okay. Wet ashing. So when we were doing dry ashing, oxygen and moisture, oxygen in the atmosphere and moisture we had in our sample, and combination of oxygen, moisture, organic compounds, and high temperature result in oxidation of organic compounds. When we are doing wet ashing, we use a strong oxidizing agent, which is usually a strong acid, to help the digestion process or ashing. The reagents we are using are usually strong acids. acid is the acid which is recommended by AOAC, but it's explosive, so it needs special hood, perchloric acid hood. So that makes the procedure expensive and special. So usually, combination of sulfuric acid and nitric acid or nitric acid and other acids are used for wet ashing. And it's good to use combination of two acids instead of using only one acid. So in this method, we have our sample in crucible in a bottle like that, or tube. And then we add acid to our sample. Here we don't need really high temperatures like 500 degrees Celsius. Why? Because we are using an acid that helps digestion of our sample. So we put it at a lower temperature, about 200 degrees Celsius, in a heating block like this, or on a plate. So the only point is that you need to make sure temperature is stable, it doesn't change a lot. And then we need to do it under the hood. So the first step, the sample will reach a dark color, and then it gets a light yellow color, which shows digestion and ashing is complete. Wet ashing is. So with dry ashing, almost white color. With wet ashing, light yellow color. So here, because we are using a reagent, which is not part of our sample, we need to have a blend. A blend is our reagent in a bottle, the same tube, at the same temperature. So it doesn't have our sample, but it helps us to correct the effect of acid we are adding to our sample. So there are some advantages for wet ashing. First is that since we are using lower temperatures, less than 500, less than 300, so we are removing the possibility of volatilization of elements and minerals. So we can use this method for determination of mineral compounds, like the amount or content of minerals or elements. And then since we are using an acid to help digestion, oxidation time and the whole ashing process is shorter compared with dry ashing. Disadvantages. Here you are using acid and it's dangerous, it's not safe. So it needs all your attention. It's not like dry ashing that you put your sample in muffled furnace, close the door, and that's it. You go and get back after 18 hours, 24 hours. No, it needs your attention and your presence. The other thing is that you are using an acid, which are strong acids, which are corrosive. So this is another disadvantages. And the other one, since it needs lots of attention, you cannot do a lot of samples at the same time. So sample size will be limited compared with dry ashing. So it has some advantages, shorter time, possibility of determination of mineral compounds, content of mineral compounds. But there are some disadvantages. More attention, a little bit more dangerous, and small amount of samples. Microwave ashing. So again, microwave ashing is not an AOC method. You can do both dry ashing and wet ashing using microwave digestion. But point is that if you are going to do a nutrition labeling, you can't use microwave ashing for that purpose because it's not an erasing method. But you are using microwave radiation in your essay. You're using a microwave digestion unit. So that makes digestion so fast. And instead of spending hours and hours to do the ashing, you can do it in like maybe even less than 1 hour, in 30 minutes, in 40 minutes, depending on your sample matrix. Time will change, but it's way faster. And then here, because again, you are using microwave radiation and you are working under pressure, then you can use more gentle acids. You don't need strong acids. So nitric acid alone can be used for this digestion and ashing process. And again, depending on your micro digestion, you can do a lot of samples at the same time. Like this instrument, the turntable might allow you to put 20, 40 vessels at the same time. So you can do digestion on 40 or 20 samples at the same time, which is a plus. Okay, a question for you. Based on what we have talked so far, I want you to think about this question and share your ideas. You are determining the total ash content of a product using dry ashing method. Your boss, your manager, asks you to switch to a wet ashing method because they have heard it takes less time than dry ashing, which is true. Less time. Do you agree or disagree with your boss or manager concerning the time issue and why? Not considering the time issue, why might you want to continue using dry ashing and why might you switch to wet ashing? So basically you were using dry ashing method. Now you are asked to switch to wet ashing when you are doing total ash content analysis. Do you agree with this suggestion or not? And why?
Sounds like you'll be. So the importance of being able to enlarge for samples. That's important. So I would say that it's worth switching to wet ashing just because you'll get your results quicker. And I don't know if this is a repeated thing, but it could be useful.
That can be
That's not
part of, yeah, that can be part of your answer to your boss, but the main response that might convince them, yeah, it's something else. You can add it, but you need something stronger reason. Yeah.
I guess. Where you actually need people to do it is a lot. You have a lot more like that. So it's because you're actually chemicals.
I think you're close in your answers. Okay. The main reason you can convince your boss is that you are doing total ash content. When you are doing wet ashing, you cannot determine total ash content because you are adding a reagent. With dry ashing, you can determine total ash content. there is a possibility of overestimation and underestimation because of bad sample prep, spattering, burning, and other things. But as long as you do your job in a good way and do a good sample prep and have different replications for your sample, then your results will be okay. It's an AOHC method, so we need to trust it. With wet ashing, the main things for this question is that total ash content. When you are doing total ash content, regardless of time, regardless of the time you need to do that analysis, you have to do dry ash. With wet ashing, you can determine mineral content. You can determine the amount of calcium, the amount of cadmium, different minerals, but you cannot determine total ash content. This is the most important point. So this table, so chapter 16 of food analysis book is about ashing and ash analysis. This table is not for you to remember the whole numbers. No, it's just for you to have an idea about the ash content of food ingredients and products you are consuming or dealing with on a daily basis. Pay attention that these amounts are based on wet weight, and when you are converting them to dry bases, the amount of ash will be higher. Why? Because you remove the moisture, and so contribution of inorganic matter in your sample weight to your sample weight will be higher. So, as you see, based on wet bases, ash content usually is lower or around 2%. There are very few food samples that might have more than 5% ash content. Very. So as you see, many cereals and grains have about less than 2% ash content. Dairy products like milk have less than 1% ash content. Once you do any processing, you produce cheese, you add salt and different compounds, then or water, then the amount of ash will be higher. But again, still, it's around 1 to 2% based on wet bases. Again, when you convert it to dry bases, it will be a little bit higher, 1%, 2%, depending on the moisture content you have. And this is for your lab. And that's it. We are done with ash analysis. If you have any question, ask. And because we have like probably 2 minutes. And I can stay longer. So if you have any question, just ask. No question? Okay, good. Thank you.
On 5 previous.
Yes, of course. 900. Can you take my?
Yeah.
Thank you.